Welcome to the next topic, which is solving quadratics. And it sounds like it's a lot different and a big shift, and it really isn't. So we've been factoring quadratics up to this point, and well, actually more than quadratics. We've been factoring lots of things, lots of polynomials, but we're going to focus on the quadratic part of the unit, and we're going to solve them by factoring. So there's a reason we did it in this order. You factor first, and then you use your knowledge of factoring to solve these quadratics, also known as finding the roots. And over the next 8 examples, you're going to get really, really good at this. Alright, so we're going to jump right in here. Our first example looks a little different than what you have seen on your other papers. So normally it doesn't say f of x equals, because we really haven't had equations up till now. We've just had expressions. So if you ignore the f of x right there, and you just look at x squared minus 3x plus 2, that's a trinomial. We know how to factor it, and we're going to say why we factor it now. So a quadratic is another name for a parabola. So this parabola might look, I'm going to be way off here, but it's going to look something like that. Actually, I lied. It's going to look something more like that, where it actually hits the x-axis in a couple places. I probably could have looked ahead and seen exactly what this parabola looks like, but I'm being lazy right now. So it's a parabola, so it ends up hitting the x-axis in 2 places. Usually, there's cases where it doesn't. And the roots are these spots right here where it actually hits. Sometimes they're called the zeros because it's where y equals 0. And remember, y is the same as f of x. So what we're going to do is we're going to write out this quadratic, x squared minus 3x plus 2. And instead of just saying equals f of x, we're going to say it equals something specific. So notice in these spots on the parabola, the y value in both of them is 0. So we'll know what x is when y is 0. So if we put in, so if we say we want to know what x is when f of x equals 0. So we'll be able to figure out what x is knowing that. So we're going to just put 0 right here. So you don't have to think about that every time. You just need to get all of the non-zero numbers to one side of the equation and put the 0 on the other side. Once you have that, you can just factor like you normally would. So this is review. We need we have factors of 2, which would be 2 and 1. Has to be 2 and 1. So I know it's 2 and 1. I know this is x and x. But I want them to add to negative 3, so that must mean they both are negative. And that works. And it still equals 0 this whole time. So remember, we have an equation, so we have to solve for x. And this is the part where this would be brand new to you. So you're going to split this up. What we're saying is, okay, so think about when you have 2 numbers multiplied together and they equal 0. One or both of them have to be 0. There's no other way to get to 0. So we say, okay, what if x minus 2 equals 0? And then what if x minus 1 equals 0? And then we're going to say, alright, I just want to see what x is. So in this case, it's 2 minus 2 equals 0, but I'm still going to show the algebra step. Add 2 to both sides, x equals 2. Over here, you add 1 to both sides, x equals 1. So I'm actually not that, well, I am far off. So if you look at my picture, I didn't guess right. So it hits at x equals 2 and x equals 1. So it's actually something more like, I can't draw here very well. So it's something like that, where it hits at 1 and it hits at 2. So that's basically it. We solved the problem. We found the zeros. We found the, we also could say the x-intercepts, although those are coordinates. So the x-intercepts would be 2, 0, and 1, 0. And notice, it's not really that much different from just the factoring part. We stopped here in our problems in the last 3 classes. This is where we would have stopped. And it usually is just the opposite sign. So x, we chose 2 and 1, or negative 2 and negative 1, and they're just the opposite, 2 and 1. Alright, let's try a different example here. So we have f of x equals x squared minus 49. So again, we're going to set this equal to 0. So instead of f of x, we're going to write 0 equals x squared minus 49. It really doesn't matter which side the 0 is on. I'm going to factor x squared minus 49, and you should recognize that as dots. Difference of two squares, we're going to say x plus 7 and x minus 7. And again, it equals 0. I just moved it to the other side. And I'm going to set individually x plus 7 equal to 0 and x minus 7 equal to 0. Well, in this one I bring 7 over, I subtract it, x equals negative 7, and this one's the opposite. I add 7, x equals 7. And again, those are my roots. If you were to plug that into your calculator, it might be an interesting thing to check. It would be, you put y equals x squared minus 49, and you should see the parabola hitting at negative 7 and 7. And you can check the table, you can check the graph. It's kind of neat that you can do that by hand. You might be saying, why, if we can do this on the calculator, why are we doing this by hand? It's because on the Regents, this is what they're going to look for. And some of the questions, they'll say solve algebraically, and you have to be able to show this. You cannot just go to your answer and say I did it on the calculator. They won't accept it. Alright, let's try a different example here. So this time there's no f of x because the equation is set up where there's numbers on either side. But we still need to set it equal to 0. We still need to see what x is when y is 0. So you need to get everything over to one side. So we have a little bit of work to do up front this time. We're going to add 15 and add 15. Now, there's nothing to add 15 to over here, and that's okay. We don't really want to add it to something. We just want to have it be on that side. So we're going to say c squared minus 8c plus 15 equals 0, because notice there's nothing left on the right side, so that's why we put a 0 now. And again, we just factor like we normally would. So we get C, C, CC. Has anyone ever been to CC's Pizza? I see commercials for it all the time. I don't even know where they live. Anyways, it's not as funny when I can't hear people laughing at my stupid jokes. Factors of 15 would be 3 and 5. And they both need to be negative so that they add up to negative 8. And again, I set it equal to 0. You kind of get the picture already. This kind of gets boring to watch me do this every time. Oops, equals 0, equals 0. And I'm going to add 5. That's getting sloppy. I'm going to add 3. C equals 5. And C equals 3. Again, on a test you would use your calculator as a check. You can't use it as the only thing, but you can definitely use it as a check. To use your calculator, you actually have to do this step still, because you can't enter this original equation into your calculator. It always needs to be solved for y, and we just replace y with 0. So again, those are our two answers. There are two roots. Alright, another example, and I know we're doing a lot of examples here, but these go quick, and I want you to be able to see what every kind of problem might look like, so you're not surprised. So this one's different. It has no constant term, so there's no third term after this where there's just a normal number, so we're going to factor this differently. This is not a trinomial, so we can't trinomial factor this. It's not dots either, because it is a difference. This is a perfect square. This is difference, but this is not a perfect square. So we can't use dots either. So instead we go back to the original way we can factor things, which is GCF. So I can pull a D out of both of them. And what I'm left with is D minus 2. And again, I still have it setting equal to 0. All I did was split this apart. The 0 didn't go away. Alright, and I still do what I did before. I split the two factors up, set both of them equal to 0, And there's not much to do with this one. That one's done. D equals 0. That's one of the roots. So if you were to graph this on the calculator, you'd see that the parabola goes through the origin, 0, 0. And the other 0, or the other root, the other answer to our problem is 2. So it goes through 0 and 2. So it maybe look something like this. You can see how close I am. I know this is an interesting one. This would have showed up on a factor completely part of your work. And we can pull a 2 out. So it's GCF like the last one. You can pull a 2 out. And you get x squared minus 16. And that still equals 0. And you can recognize this as dots. But what do you do with 2? Well, we're not quite there yet. Let's leave it there, and then let's factor this into x plus 4, x minus 4. Now we say each part equal to 0. Eventually, we won't do that because it's just a throwaway thing. So obviously 2 does not equal 0. It just means that wasn't the thing that was making this equation equal to 0. So it pulls out. It doesn't affect anything. If we had left it in there, it would have worked itself out a different way. But essentially, when you just pull a number out, you can just ignore it. And then x plus 4 equals 0, x minus 4 equals 0. This one will end up being x equals negative 4. This one will end up being x equals positive 4. And again, check it on the calculator. Make sure I'm not lying to you. It's kind of neat to just see how it works every time. Okay, so this is an interesting one. Obviously, it looks way different. There's fractions. I don't even think of these as fractions, because you don't really have to remember much about fractions. What you do want to remember is that when you set two fractions equal to each other, you can solve by cross-multiplying. So we're going to multiply x by x plus 5, and we're going to multiply 2 by 12. So that's an easy part. That's 24. But I'm going to do the other part first here. I'm going to do x times x plus 5. And you have to have parentheses, because if you don't, you're just going to end up multiplying x by x, and the 5 won't even be a part of this action. So you want to make sure you put parentheses in, and this is distributing. So you end up with x squared plus 5x. And then that equals to the other cross multiply, which is 24. And it really is now just like that problem we saw a couple equations ago, where we have to get everything to one side. So you just have to subtract the 24 so that it's gone from over here, and then subtract it from this side so we keep things even. And I'm going to come up over on this side here, rewrite it, x squared plus 5x minus 24, and that is set equal to 0 again. And once again, I just do some normal trinomial factoring here. So factors of 24 that add up to a positive 5, so I need one of each sign, x plus something, x minus something. I want the bigger number to be positive. Let's see where we're at. I think 8 and 3. So 8, 3. 8 plus negative 3 is positive 5, so it works out. And then this one will be negative 8, and this one will be 3. Notice how I kind of skip steps now? So you get used to just seeing that once I set this equal to 0, it's just going to move to the other side and switch signs. So I kind of just do this in one step eventually. After you get good at it, you can do that too. We are almost done, I promise. There are 2 slides left, this one and one more. And this is interesting. It doesn't look really that weird at first, but something happens. So you can pull a 3 out, so you get 3 times x squared minus 2. That's not dots. You might think it is at first, just because you're expecting something like that, but it's not dots. 2 is not perfect square. You can still set it up 3 equals 0, which that's the throwaway one, and then x squared minus 2 equals 0. Well, you can't do this. This is not a factorable expression. So let's erase that. let's think. How do we do this then? So you have to go back to just solving the equation like you normally would have. Before this unit, you would not have solved by factoring. You would have just tried to get x by itself, and that's what we're going to have to do this time. As long as we don't lie to ourselves about the algebra steps we're allowed to do, as long as you follow the same rules, we can do it a different way. We can do it this way: x squared equals 2. So now how do we get back to just x? So we've done this before, I think. So we just take the square root. If x is squared, we take the square root, we get x equals, and now we have square root of 2, which is not a perfect square, so you just leave it the square root of 2. But you also, so if you're really thinking, or maybe you graph this on the calculator already, shouldn't there be 2 roots? Right? If the parabola hits in 2 places, why am I only getting one answer? Well, it's because when you take the square root of something, let's take the square root of a nice perfect square like 9. We all know that it's 3. But we've only ever told you the positive root, or the positive root of 9, which is positive 3. But there's also the negative root. So we say plus or minus 3. And in this case, same deal. We say plus or minus negative 2. So it's a positive, not negative 2, plus or minus radical 2, also called square root of 2. We had a whole unit called radicals that we used to get to do in algebra when it was integrated algebra. And it's just another name for square root. So square root and radical mean the same thing. So if you hear me slip and say radical 2, that just means the square root of 2. So that's our answer. We'll practice more of those. That might have gotten confusing, but we'll definitely do some more of those in class. One more, and it's a word problem. I apologize for my terrible writing on this app. I'm using a little teeny yellow stylus, and it's got the worst pen tool in the world. It makes your handwriting look hideous. But I think you can read it. It says, write the equation of a quadratic function with roots of 5 and negative 4. So what they're giving you are the answers. So those are the answers that we normally would have gotten. So if I just learned something. I can't go backwards while I'm recording. So if you look at any of your the other examples in your notes, we came up with 2 numbers at the end. They're telling us the 2 numbers, and we need to get back to an equation. So you start by saying, all right, if the roots are 5 and 4, then it would be x equals 5 and x equals negative 4. And we're just kind of like reverse engineering it. So if you just follow the steps backwards, then this is what we did. We wanted them equal to 0. So we bring these numbers back over to the left side, and we get x minus 5 equals 0, and x plus 4 equals 0. So again, I just brought them back to the left side so that they're equal to 0. Now, you can think of these as the 2 factors, and we can put them together. X minus 5, times x plus 4, so that's supposed to be an x there, equals 0. So this is like the pre-split. So normally we would be going that way and split them up. Now I have to multiply. So this is back to the grid. I don't know if anyone's heard of FOIL. If you had older siblings who might have gone through algebra, there's something that people just can't forget. It's called FOIL, and it stands for first, outer, inner, last. And it was our way of multiplying 2 binomials. But then they added to the curriculum that we had to not only multiply 2 binomials, but sometimes a binomial and a trinomial, or 2 trinomials, or just even bigger. So the grid method works no matter how big the polynomial is. So we switched over to that, and we really don't talk about FOIL anymore. But FOIL is something that works on this problem. But I'm going to use the grid anyways. This is x squared. This is 4x. this is negative 5x, and this is negative 20. And I combine my middle numbers, and it gives me x squared minus x minus 20. So this is this, just multiplied together. So it still equals 0, just like this one did. And I'm done. It says write an equation. This is an equation, but you could also change your 0 to f of x if you wanted, and your final answer could look like either of these things. So it could look like this, or it could look like this. They are both equations, so we're doing what they want us to do. And they're both fine. This one we're just saying that y is 0. This one we're saying it's y.